You're talking about, let's write a general form of polynomials. You're looking at f of x equals a, f of x equals ax plus b, f of x equals ax squared plus bx plus c, f of x equals ax cubed plus bx squared plus cx plus d, and we continue like that to a higher order. So we're going to say this is a first order polynomial or constant. So this is constant. This is linear, it's a line. This is quadratic. And this will be cubic. Okay, the next one up will be quartic. And so on. So first, this is zero order, first order. So here I'll put order. Order is the power, the highest power in the polynomial. So this is the same as a times x to the power of 0. So the order will be 0. This is a times x to the power of 1. So this is first order polynomial. We have 2. So it's a second order polynomial. Third order polynomial, the quadratic will have x to the 4th in it. It's 3.1 actually. Okay. So we are looking at this particular function right there, and this is the general form. Now, the standard form of polynomial of a quadratic function looks different. Standard form of a quadratic you probably recognize it as the vertex form of a quadratic function. It's going to be f of x equals some coefficient a times x minus h squared plus k. Okay. Again, we learned it probably as the vertex form, but in these textbooks and other textbooks, this is actually called the standard form, while the general form, which we had here, was called the standard form. Okay? So there is a little bit of adjustment in nomenclature. So what we call standard form is, at least in this course, we'll call it general form, and what we call the vertex form is what is now the standard form. In your assignment, every time you're asked to do the standard form, it means that we need to do the vertex, and the vertex can be read directly from this expression. The vertex is the coordinate xy that are hk, like so. Okay, so this is a little bit more convenient. What about the role of the coefficient a? Well, you probably remember that if a is positive, the parabola, the graph of the quadratic function, opens up. And if a is negative, then the parabola, the graph of the quadratic function, open down. In calculus, we're going to talk about maximum and minimum problems. In a is directly related to the maximum minimum, which I want to address right now. So the coefficient a, if a is positive, then the parabola opens up I'll put opens up in quotation mark, and the function has a minimum because it's open up. Okay? And where is the minimum? Well, the minimum will be at the vertex. So the minimum will be at x y equals hk. Okay? If the parabola, if the coefficient is negative, then the parabola opens down. The function, because it's open down, the function has a maximum, and the maximum happened at the coordinate of the vertex as well. So at xy equals hk. And this will be our main interest as far as analyzing a quadratic equation. The next thing to look at is what happened if we go back and look at the vertex form right here, ax minus h squared plus k. If we start with the base parabola, the function f of x equal x squared has a graph, or the graph, of the base parabola. Okay, so the base parabola, the coefficient is 1, so it's open up. When x equals 1, y equals 1. When x equals 2, y equals 4, and so forth. So this is the base parabola. Okay. What happened if we look at the transformation? If we look at the following function, given f of x equals, let's say, negative 2 x plus 3 squared plus 5. Okay? And the question is, name the transformation that were applied on the base parabola to obtain f of x above. Okay? So the question is, what have we done to go from y equal x squared to negative 2 times x plus 3 squared plus 5? So we started with the base parabola. So let's see, the point, 1, 1, negative 1, 1, and then 2, and 4. So 2 and 4 is about right here, and negative 2 and 4 is about right here. And if I'll draw a curve passing through these 4 points plus the origin, I get the base parabola like so. So this is y equal x squared. So what have we done? If I'm looking at what we have here compared to what we started with, and we need to follow order of operation here. So we start with the parentheses, and we have x plus 3. Well, that will be shift to the left. We didn't talk about the rigid and non-rigid transformation when we review the transformation, but there are transformations that we call rigid transformation and those that are not. Rigid transformation is transformation where we don't change the shape of the graph. Okay? We move the graph as is, to the left or to the right, up or down. Non-rigid transformation is where we stretch and compress. Because as we stretch and compress, we change the shape of the graph. Furthermore, if you look at the reflection, whether it will be reflection about the x-axis or the y-axis, once again, we do not change the shape of the graph. So in addition to shift up, down, left, right, reflection about the either axis or any axis is also called rigid transformation. So the first transformation is a rigid transformation. We simply move the parabola to the left. So the vertex was at 0, 0. Now the vertex will be at negative 3 and 0. Okay? And the shape will be the same thing. So it will be something like that. That will be the first step. I don't know if I need to draw it. Now what we did, okay, the next thing we multiplied by 2. Ignore the negative because we multiplied by negative 1 and then by 2. So basically what we did, we stretch it vertically. So the point, if we went through 1, 1, now we're going to go 1, 2. If we went to 2, 4, now it will be 2, 8. So now we'll have a stretch graph like so. And then we apply the negative, which is basically a reflection about the x-axis. So the second transformation was a non-rigid transformation. We stretched, and then we flip it over one, let it go. Don't use that now. And this is a rigid transformation of the previous one. And finally, we added 5. So instead of having a vertex at negative 3 and 0, we climb up and we get the vertex at negative 3 and positive 5. So here's the final product. I'll draw it in red. So everything else was intermittent steps. So if I it's supposed to be x minus h, but we have plus. So if you think about it, this is x equals negative 3 is the vertex. The vertex will be negative 3 and 5. If you subtract negative 3, you have positive 3. Okay? So okay, we can write it as negative 2 times x plus negative, x minus negative 3, like so, squared plus 5. So vertex hk equals negative 3 and positive 5. Okay? Makes sense? How we find the standard form is the next topic.